Map address plus port. As long as this variable is different, we can uniquely locate such a data. And then convert. Equivalent to a larger convertible space. So it saves our IP address even more. There are two methods we most commonly use now. It can also define a public network address pool. For example, I can also have 10.1, 10.2, 10.3 etc. This is also possible. In the address pool, data sent by hosts. First take the first address and different port. First run out. Make a second one. The second is exhausted. Get a third. You may ask, how can it be possible to run out of 65,535 ports? Generally speaking, there are about 100 people in the company. Almost can exhaust so many ports of an address. You should know. A port is not a device that only generates one mapping. Now the same device has many programs open. For example, listening to music, watch a movie, playing games. Now overall, a device may have dozens of processes accessing public network services at the same time. It consumes dozens of ports for accessing the public network. How do we judge the mapping? As long as the device wants to access the public network address plus port is different, it will have a piece of data out. When the data is sent out, a mapping will be generated. Therefore, our daily internet consumption consumes a lot of ports. For enterprises, it's almost the 100 people I told you. Basically, a public IP port is almost used. Of course, if there is not much demand for internal internet traffic access, you may find that 200 or 300 people are enough. But if your daily demands are too high, about 100 people are almost exhausted. So sometimes we will define the public network address pool. But for the vast majority of small and medium-sized companies, none of us do it this way. Because the public network address has to be bought. It still has a cost problem. So what we use most now is, although there is no public network address pool, but it has a public network address. The outbound interface that RA is now connected to the operator is a public network address. Then I will no longer define the public network address pool. I just use this interface for conversion. For example, this is the address of the interface. Future traffic will be based on this interface. Then just do it on a different port. I don't need to spend any more money. It is 10.1. Let's say it's 10.2. I still have to pay for a 10.3. Then map the address and port to it. Don't do this. I just use this 10.1. This is a public address. In Cisco, we call this method the conversion of the outgoing interface. And this command is bound under the outgoing interface. The outgoing interface address can be changed. To use the changed, it does not matter how. The address of the external network interface changes. So now for many companies, how we use the internet. Not a fixed IP. We use the form of PPPoE. Every time I dial up, the obtained public IP may be different. But this does not affect us to do NAT. Because we can use the public network interface. Do the corresponding NAT conversion. Then the interface of the device is 1.1.1.1. I just use the 1.1 port. The interface of the device is 2.2.2.2. It dials up to get a new address. I just use its interface. Because this command is bound to this interface, rather than a fixed address. So it doesn't matter how the interface changes. Let's demonstrate. The device is now rebooted. These should all be empty configurations. No. Not an empty configuration. I have configured the address. Then let's look directly at the configuration. The full name of PAT is Port Address Translation. I first check if the command just now is saved. Show run. OK. I just turned off the router. The PC should be all set up. After setting up the PC, we are now going to configure a default route for this gateway. IP route 0.0.0.0, 0.0.0.0.0. The next hop is 100.1.1.2. After we enter this default route, still need to configure ACL. Access list 10. We still use the same traffic as before for crawling, or to allow the two internal PCs to access the internet. We match 192.168.1.0 this time. 0.0.0.255. It was any just now. We now match the 1.0 segment, plus a wildcard. Then press enter. We're done now. It is equivalent to getting multiple internal IP addresses. Now I'm going to map it to an external interface. IP NAT inside source. This is constant. Then I still associate it with list 10. I enter a question mark. What we just entered is pool. Defines a starting interval to an ending interval. We now use interface. I hope that the traffic will be converted to this 00 in the future. The address of this 100. 1.1.1. I want to use it. Ethernet 00. Then enter the last command. Overload. Port multiplexing. That is, after the port is used for you, it can be released and used by others. We understand now. Port multiplexing. Press enter. Then when we press enter, there is another one we haven't configured yet. Remember the 3 steps I said? After first getting this traffic, you have to convert. But there are 2 key. We at Cisco must remember. Under the interface, make sure it is an external network interface and an internal network interface. Traffic must come in from the internal network interface. Go out from the external network interface. Then match the corresponding conversion. It can be NAT. Our 2 interfaces are not set. We also need to set interface E01. Get in here. IP NAT inside. Still have to wait here. Here whether you enter inside first or outside first. Need to wait a long time. This is a habit of its overall configuration. Probably for this order. The device is a little slow to process. But you enter the second command very quickly. Maybe there is something wrong with my mirror. I haven't seen this before on a real machine. Interface E00. IP NAT outside. We are now set. After setting, it is equivalent to. Now go to ping the 2 PCs. See if it works. Ping 8.8.8.8. Same here on PC 2. Ping 8.8.8.8. Let's get ready. Make them both a little bit at the same time. Okay. Let's see. Both work. You will find the commands we configure are different, but does not affect their communication. Show IP NAT translation. Here is our mapping table. Now you will see the contents of the mapping table. Inside local. Here are the 2 addresses inside. 2 addresses carry 2 ports. But ICMP does not belong to layer 4. ICMP is a layer 3 protocol. It is encapsulated on top of the IP layer. But it seems that there is no concept of port in it. ICMP has no port. So for some of these services without port, it is followed by a serial number. If you access other ports in the future, it is a port. But for ICMP, this is a serial number. Just know it. You can think of it as a port. Doesn't matter. 1.10, 1.20. You will find both PCs internally. The numbers behind them are the same. But it doesn't affect two people surfing the internet. This is what I just told you. We only need to have different port numbers of their outgoing interfaces mapped to the public network. For example, I am now going to get the internal address plus port map to external public network address plus port. Visit out. Future data will return to port 1 of this 100.1.1.1. Port 1 will be uniquely positioned to 1.20. So, it does not matter whether the ports of the two internal addresses conflict or are consistent. Because the outside is different, we find the internet address based on the difference from the outside. So it definitely returns exactly. So it works. Doesn't matter if it's the same inside. It doesn't matter if you repeat. We are looking outside.